Number 17, we're simplifying this cubed root, the cube root of 128. So let's factor this. 128 is not a perfect cube. We try factoring it. We try to divide by 2. All right, and it is divisible by 2. 128 divided by 2 is 64. And remember, 64 is a perfect cube. Remember the perfect cubes, 2 cubed. Let me just remind you, 2 cubed is 8. 3 cubed is 27. 4 cubed, 64, and 5 cubed is 125. So there are some perfect cubes. All right, so this comes out 64 comes out as 4. And so we have a 4 in front, and that's times the cubed root of 2. Okay, let's look at number 18. We want to add these radicals. They're not like radicals, so we're going to simplify, and we're going to try to get like radicals. All right, so we want this second radical to end up with a 5 underneath, because here we have radical 5, and this first one can't be simplified. All right, well, this does factor. 40 does factor into 8 times 5, and 8 is a perfect cube. So we can take it out. 8 is 2 cubed, and we have 5 cube root 5 plus 2 cube root 5, which leaves us with 7 cube root 5. In number 19, we want to combine some radicals that are not like radicals, so we'll try to simplify and get some like radicals. Always simplify the easier one first, so we'll start with the square root of 45. All right, and that's 45 factors is 9 times 5. 9 is a perfect square. 3 squared, so a 3 comes out in front. So we're left with a 5 in this radical over here, so we want to be left with a 5 here as well. So we'll try dividing 320 by 5, and 320 is divisible by 5. It's 64 times 5. 64 is a perfect square. All right, it's 8 squared, so this is equal to 8 root 5 minus 3 root 5, and that's 5 root 5. In number 20, we're just multiplying radicals. Okay, so we have 5 times 2 is 10, and radical 3 times radical 3 is 3, so this is equal to 30. Okay, here let's multiply these radicals in number 21. So let's do that. So underneath the square root we have 25. X cubed times x, that's x to the 4th. And y times y to the 5th, that's y to the 6th. So after we multiply, we do get a perfect square. Each factor here is a perfect square, so we can take the square root. The square root of 25 is 5. The square root of x to the 4th is x squared. Just divide that exponent in half. And the square root of y to the 6th is y cubed. In 22, we're multiplying two radical expressions. All right, start with 3 times 2. The first times the first, that's 6. And now the outer product, that's minus 9 square root 3. The inner product is plus 10 square root 3. And the last here we have minus 15 times root 3, that's 3. So here we have a 6. This is 6 minus 45, so that's a minus 39. And here we have minus 9 plus 10, so that's plus 1 root 3. In number 23, we're dividing two radicals. So we divide underneath the radical sign. So we can put this under one radical. Okay. So we're dividing 8x to the 5th y divided by 2xy. And here we divide 2 into 8, so that's 4. And x divided into x to the 5th, so we have x to the 4th. And these y's just cancel. Okay, so we're left with 1 down there. So we can take the square root. This is a perfect square, and we get 2x squared. Number 24, we're rationalizing a denominator. So we have 6 divided by 5 square root 3. And we'll multiply top and bottom by radical 3. And what that does in the denominator, we have radical 3 times radical 3, which is 3. So we get rid of the radical from the denominator. And we can do some canceling here. 3 divides into 6. So we have 2 root 3 divided by 5. In number 25, we're again rationalizing a denominator, but this time we have 2 terms in the denominator. So we're going to multiply numerator and denominator by the conjugate of the denominator. So that would be 2 minus 3 root 2. Okay, numerator and denominator. All right, so let's do that. In the denominator, we just have to do first and last because these are conjugates and the middle term drops out. So we have 2 times 2, that's 4, minus 9 times 2. All right, in the numerator, we'll do a full FOIL multiplication. So 3 times 2, that's 6. In the outer, we have minus 9 root 2. For the inner, we have 2 times root 2, that's plus 2 root 2. And for the last term, we have minus 3 times 2. So let's simplify that. Okay, so this minus 3 times 2, that's minus 6. All right, 6 minus 6, that's 0. And then we have minus 9 root 2 plus 2 root 2. So that's minus 7 root 2. And here we have, this is 4 minus 18. So we have minus 14. Okay, we can reduce this, divide top and bottom by minus 7. So we have the square root of 2 divided by 2. Okay, here's quiz question number 4. Copy this one down, and you can do question 4 now. In number 26, we have an expression with a rational exponent, a negative rational exponent. So the first thing we're going to do is take the reciprocal. So when we have, in general, if we have a fraction raised to a negative exponent, we can take the reciprocal of the fraction and raise that to positive 1/4. All right, now we're ready to take the 4th root of the numerator and denominator. Well, 3 to the 4th is 81, so the 4th root of 81, that's 3. And 2 to the 4th is 16, so the 4th root of 16 is 2. So we have 3/2. This is the last question on the quiz, so copy this one down now. Number 27, we again have a fractional exponent. All right, so what we do is first we do the denominator. In other words, that indicates a cube root. So first we're going to take the cube root of minus 27. So the cube root of minus 27 is minus 3. Then we still have to square. We didn't do that numerator yet. So we're squaring minus 3. Notice that's in parentheses, so when we square it, we get a positive 9. In number 28, we have an expression and a fractional exponent. So first we do the denominator, which is a cubed root. So let's do that. We're going to take the cube root of our expression. The cube root of 8 is 2. The cube root of x to the 6, divide that exponent by 3. 6 divided by 3, so we have x squared. And the cube root of y to the 30th, again, divide that exponent by 3, and we have y to the 10th. And we still have to square this expression. So let's do that. Square everything. 2 squared, x squared squared is x to the 4th. And y to the 10th squared, that's y to the 20th. Okay, here's number 29. We have 3 powers of x, all raised to fractional exponents. So when we multiply powers with like bases, we add the exponents. So that's what we'll do here. We'll just add those exponents. So we're going to add 1/5 plus 2/7 plus 3/5. So let's get a common denominator here. Common denominator of 35. All right, we'll multiply top and bottom here by 7. And here we multiply top and bottom by 5. 5 times 2, so we have 10. And here we multiply top and bottom by 7. 7 times 3, that's 21. All right, and just add up those numerators. And here we have 10 plus 21, that's 31 plus 7 is 38. Okay, number 30 reads, if one leg of a right triangle is 5 and the other is 12, what's the length of the hypotenuse? All right, so let's just draw a little picture here. So here's our right triangle. One leg is 5, the other is 12, and we want to know what the hypotenuse is. So we do the Pythagorean theorem, a squared plus b squared is equal to c squared. So that would be 5 squared plus 12 squared is equal to c squared. So we have 25 plus 144 is c squared. That's 169 is c squared. So c is the square root of 169, which is 13. In number 31, we want to find the second leg of a right triangle with hypotenuse 7 and leg 3. All right, so again, let's draw a picture. Okay, that's the right triangle. So the hypotenuse is 7 and one leg is 3, and we want to find the other leg. Let's call that b. So again, Pythagorean theorem, and we have 3 squared plus b squared is equal to 7 squared. That's 9 plus b squared is equal to 49. Now just subtract 9 from both sides. And we have b squared is equal to 40, or b is the square root of 40. This can be simplified. 40 is 4 times 10. So we can pull out that 4, and we can get 2 square root 10. In number 32, we want to determine if 7, 24, and 25 are the lengths of the sides of a right triangle. So what we want to know is, well, 25 must be the hypotenuse because that's the biggest side. So we're asking, is a squared plus b squared equal to c squared? So we want to know, is 7 squared plus 24 squared equal to 25 squared? Okay, that is 49 plus 24 squared, that's 576. is that equal to 25 squared, which is 625? Okay, and the answer is yes, these two sides are equal to one another. Okay, so 7, 24, 25 are the lengths of a right triangle. Okay, in 33 we're finding the area and perimeter of a rectangle with length 5 and width 3. Okay, so the area is length times width, so that would be 5 times 3. And that would be square units, whatever the units are. The perimeter is twice the length plus twice the width, so that would be 2 times 5 plus 2 times 3. So that would be 16 units, whatever the units are. In 34, we want the area of a triangle whose height is 4 and base is 7. So this is the formula for the area of a triangle, 1/2 base times height. Okay, so we have base 7, height 4. So we want 1/2 of 7 times 4, 1/2 of 28, which is 14. And that would be square units. And finally, in 35, we want the area and circumference of a circle with radius 4. So let's remember the formulas. The area, that's pi r squared. And the circumference is 2 pi r. So we have radius 4. So that's pi times 4 squared. Okay, so we write that 16 pi, and that would be square units. All right, and circumference 2 pi r, that's 2 pi times 4. So we'll write 8 pi, and that would be linear units. Okay, that's the end of our review. So good luck with your studying.